Oh, Math Gad guys, welcome to today's video about combining opposite numbers to make zero, how that works. So we're gonna see basic concepts about opposite numbers again, and we're gonna combine them and do some problems. And before we begin the video guys, very important that you hit that subscribe button, that like button, and that notification button, so that trifecta, in order to notify yourself whenever I upload a video. Without further ado, let's begin.
Oh my God.
Hello guys, welcome to today's video in which we're going to be learning why combining opposite quantities make zero. Or do they? Okay, let's begin. Okay guys, so in order to understand the concepts of today's video, we're going to be seeing and taking a look at two real-life situation problems that help us understand why when we combine two opposite numbers, the answer is going to be zero. So the first problem talks about Eliza. Eliza was buying clothes for her mom's birthday party at the mall. She was on the ground floor when she realized she had left her phone in the car. She walks down 2 floors to her car in the underground parking garage. So the question they ask us is, how far will Eliza walk to get back to the mall's ground floor, right? So the first thing we see here, guys, is that this problem is better understood when we take a look at the number line. So Eliza starts in the ground floor, right? So Eliza starts here. But since she forgets her phone, she goes back not 1, but 2 floors. And now she is here in the car. And again, they say, how far will Eliza walk to get back to the mall's ground floor? Right, so she has to come back again. So she comes back up 1, 2 floors. As you can see, she moves down 2 floors, which is again expressed as a -2 because the movement was down. And then she goes back up 2 floors, right? So that's +2. So how far would Eliza walk to get back to the mall's ground floor? 2. Because -2 plus 2 is going to be 0. Why is that? Because she started in the ground floor, she went down, and then she came up 2 floors, and she's still in the ground floor, right? So let's say Eliza had to go down 3 floors, right? So she goes down 1, 2, 3 floors. So she's now in -3. But if she has to go back, she has to move 1, 2, 3 floors back up. So she moves +3. And she's in the same exact position. So her overall change is going to be 0, right? That is something that you can actually see that it doesn't really matter if she goes down or she goes up. The number is going to be the absolute value of 2 or the absolute value of -2, right? It doesn't really matter if she goes up or down. She's going to move. She's going to go up or down 2 floors. And that when we intertwine -2 +2 or +2 -2, the answer is going to be 0 because there is no change in her position, right? So that means that whenever we have a negative number like -6 and we add the same number but it's opposite, our answer is going to be 0. So we have a bonus question. How can we represent the change in floors without considering the sign, right? So we know that whenever she came 1, 2 floors down, it was represented by a -2 because again, the movement was down the ground floor. And when she came back up again, the movement was 1, 2. Again, a +2. But the question here says how can we represent that change of floors without considering the sign? That's where the absolute value takes place. So the absolute value doesn't care if it's -2 or +2. It just focuses on the outcome. The outcome is 2 floors. It doesn't matter if it's up or if it's down. Eliza walked 2 floors twice. Okay, so let's try another problem. So this problem is of Dennis. So Dennis has $30 in his savings account. Gabriel gives him $50 for his birthday. 3 days later, Dennis decides to buy a new console game and spends $50 on it. Wow. How does Dennis' savings account balance change? Okay, so again, we have the same thing with the absolute value here. We have Dennis. Dennis doesn't start at 0. Dennis starts at $30. But then Gabriel gives him $50. So again, he receives $50 plus 50 for his birthday. And now he has 80. But then again, he decides to buy a new console game and spends $50, right? So he goes back $50. What that means is that his net worth didn't change. He had $30. When he added $50, he ended up with 80. But again, when he spent $50, he went back to 30, which is the amount of money he began with, right? So with this, we can know, guys, that we have any number and we add two opposites. So for example, if we have 8 and we add two opposite numbers like +6, -6, the +6 and the -6 are not going to affect 8. It's going to remain unaffected. Why? Because when we combine these two, the overall change is going to be 0, as we learned in Lisa's problem. So 8 plus 0 is going to be 8. And again, we have to remember that two opposites, like for example, -50 and +50, have the same absolute value. That's why whenever we have a number like this one with Dennis, it doesn't really matter if we move forward or backwards. If we move the same number or the same amount, it's not going to really matter. The change is going to be of 0. Because whenever we combine two opposite numbers, the answer is going to be of 0. So you can see, guys, in this problem and the one before, whenever you combine two numbers that are opposite, the change is going to be, again, 0. So what can we conclude about combining opposites? The first thing we can conclude is that anytime we combine opposites, again, the result will always be 0, right? Let's tackle the following expressions, guys. And if you feel the need, pause, try solving it yourself, and then compare the answers. So the first one is -5 plus 5. Again, we have 5 and half 5, and we have negative and positive. So they are complete opposites, and the rule says that whenever we have two numbers that are opposite, the answer is going to be 0. So -5 plus 5 is equal to 0. Well, now we have 1,500 minus 1,500 plus 4. Again, we just have to take a look at the 1,500. So in both cases, we have 1,500, but again, we have a positive and a negative one. So when they combine, you have 0. So 0 plus 4 is going to be 4. Any number added to 0, it's going to be that same number. So remember that always, guys. Again, we have decimals. So this does not just apply to numbers like integers. It also applies to decimals and fractions. So -34.9 plus 3.49, again, they are the same number with different signs, meaning they are opposites, as you guys learned in yesterday's video. So -34.9 plus 3.49 is going to be 0. Again, we have fractions, but these fractions, we have -100 plus 51 divided by 100, which is the same number, and then we have a 3 divided by 7. So whenever we combine these two, because they're opposites, the answer is going to be 0. Negative 3 divided by 7. So 0 minus 3 divided by 7 is going to be that same second number. So minus 3 divided by 7. And now we have the last problem, which is 13 divided by 14 minus 13 divided by 14 minus 53 plus 53. So again, we have two sets of opposite numbers. So these two, when combined, give you 0. And then these two, when combined, they give you 0 because we have a negative and a positive one, a positive and a negative one. So these two also give you 0. And when you add 0 plus 0, it's still 0. It's not going to change. So again, guys, whenever we have two numbers and they're opposite and we're combining them or adding them, the net change is going to be 0. And whatever thing you have next to them is going to make the difference between 0 and that number. Okay, guys, so I hope you guys understood today's video. Feel free to check out tomorrow's video and yesterday's about understanding the concept of opposite numbers. And I'll see you guys on the next one. Bye, everyone.
Check out these other videos to improve your math skills, and make sure you click that subscribe button to make the community grow. Follow OHMATHGAD in its social media accounts, drop a like, a comment below, and see you on the next one. Bye!